Hello, everyone, and welcome to episode number 122, which is the first of a two-part episode or two-part echo series talking about Cilium 115. The funny thing is that this one is actually happening right before the release, so I'm going to give you a little preview into what's actually happening, and we may even get into like how to actually do to install it and test it out if you're curious about some of the features that are coming. As always, if you're out there, let us know in the comments. It's always great to have you with us as we work through these Echo episodes. And let's jump into what's happening in the news. So, as always, if you go to cilium.io/newsletter, you're going to be able to find all kinds of good stuff. Our GitHub, a link to GitHub. You can join our Slack. You can also look at the previous newsletters or sign up for the newsletter here on the bottom. All that is possible. The most recent one we have is episode 47. And some of the stuff that like Dan Finneran, a good friend, has been playing with lately has been pretty crazy to see. But yeah, definitely check that out if you're curious about it. But Dan spent a few hours writing a bunch of protocol parsing stuff. He played a bit with BGP and was able to like actually manipulate BGP protocol in eBPF, and has now since done so with DNS because it's always DNS. So there's lots of fun stuff to watch there. You can find him on X, but he's been doing a lot of really neat stuff there, and actually has published all of his code publicly. So if you want to play with, you want to see what he's been getting up to and see how all of that works, you're very welcome to go check that out. So load balancing for Kubernetes services using BGP with Cilium. Somebody else wrote a blog about this. I think I actually can't remember if I just recently covered this, but I don't think I've done a public one yet. We should do that. I actually just explored doing OpenShift with BGP, and so we should probably do an episode on that maybe coming up after, especially now that there's been some changes in the 115, introducing things like being able to introduce BGP communities, BGP MD5's password authentication for BGP, all that stuff is happening. So this is actually a pretty good overview. They're talking about in 110, we vendored in Metal LB, which allowed you to do load balancers via BGP. I think they're using that though. They're not actually using the newer BGP stuff. But you know, it's in there still. It's still working. That's pretty cool. What else do we have? Unveiling eBPF verifier errors. XTP and eBPF network observability with Python. Kubernetes on FreeBSD with Linux worker nodes and Cilium. That seems like a pretty interesting setup. A newer Azure Terraform module for deploying Cilium on AKS clusters. An eBPF stealth container meant to make offensive tools fly under the radar of systems administrators. I haven't seen that one yet. Might go check that one out too. And lots of other really good stuff. In the technical and in the how-to, we have things like how to migrate from OpenShift to SDN. This is an interesting article. I don't know if I've ever done this publicly, but this is actually something I worked with, something I helped write. And so this is a really interesting one because it gets into some of the real intricacies around the way that OpenShift does its thing. So an interesting blog. Definitely check it out if you are in the process or considering how to do this. But understand that when you do it, you might be peeling the what do you call it, warranty label to get down to some of the components that you're making changes to. So be careful with that. A Cilium dual stack K3S, demystifying Cilium, learning how to build an eBPF CNI from scratch. That's pretty neat. A tutorial from KubeCon, kind of a breakdown, give me a little more information into it. Yeah, lots of good stuff. So I'm also being joined in this episode by two of my coworkers, Mr. Ryan Drew and Mr. Joe Stringer. Welcome, gentlemen.
Hello. Hey, Duffie. Good to see you.
Let's do some intros. I'm going to pass it over to you, Joe.
Hi. I'm Joe. I'm a co-maintainer on the Cilium project. I've been working on networks and the kernel and stuff for some number of years now. But yeah.
I think of Joe as like the person who has like most of the mental model of Cilium in his head most of the time, which blows my mind. But that's definitely the picture of you in my mind of like having somehow managed to fit all of what's actually happening in there. Mr. Ryan Drew.
Yeah, so I'm a performance and scale engineer at Isovalent. Been here for about 2 years, so just kind of doing everything that we can to increase performance and scale in Cilium and Hubble.
Nice.
So a lot of cool testing are going on.
You're going to be telling us a bit about KB Mesh Store, which will be changing in 1.15. Pretty exciting stuff. Mm-hmm. So a couple of things I wanted to share a little bit more about. And gentlemen, if you have something you would like to share about this as well, feel free to do so. We're coming up on Paris, so Cilium in Paris. We'll see you there. We have a new exam, the Cilium Certified Associate Exam. We are again doing eBPF Day or Cilium and eBPF Day. So in this case, I think we're kind of combining the two terms. If you've watched over the last few KubeCons, it's been like Cilium Day, and then it was like eBPF Day, and then it was eBPF Day for a long time, and then eBPF and Cilium Day. So this one is now Cilium eBPF Day. So we'll have people coming to us from a variety of places in the community, coming in talking about either Cilium or eBPF. Lots of really great stuff happening. We're going to hear from my friend Kyle Quest again, which I'm excited about. We have folks like Laurent Brunel from Datadog and Bill Mulligan. I believe they are hosting. I think they're hosting. And then we'll hear from Hemant and Joe Stringer. You'll be doing your talk. I got a talk waitlisted in here. We have Hector Monsalve and Edgardo from Roche talking about how Roche manages network connectivity for 1,000 or more edge clusters. That's pretty interesting stuff. Somebody from Solo.io talking about supercharging Kubernetes with Cilium and IPv6. Is that like the same title as the one? That's confusing. I feel like, no, that was a different one. I was thinking of the talk, last year. Anyway, JVM and TLS. Wow. It's a lot of four-letter words.
Some crossovers there that you don't always hear about in the eBPF community, right? There's some hardware, some lightning talks and stuff as well, right?
Yeah, I think so. Speed running through splicing sockets with SockMap. I don't think I could actually say that like 5 times fast.
Yeah, Jacob there is a good friend from the Linux community, and he does some good work, so I'm actually looking forward to that one.
So he's been at Cloudflare for a while?
Sometime, yeah, for sure.
Nice.
Yeah, he's given some talks on those topics, I think, at some of the Linux plumbers conferences, that sort of thing.
Oh, very cool.
Yeah.
And we have Taming Noisy Neighbors with Cilium and eBPF from Anton at Datadog. Yeah, lots of really good stuff happening in there. Should be a fun day. So this is a one-day event, and so it should be a fun one on the 19th of March. And also, I always do this, and I sometimes forget to do it, but I actually only just now noticed that rejects.io is now available, and you can actually get your tickets for free if you register now. And then the only cost would be to arrive like 2 days early, so you can go and check out the Cloud Rejects conference in Paris, France, on March 17th and 18th. So if you are going to if you're going to Paris anyway, if you show up like a day or even 2 days earlier, you're going to have a really great opportunity to really connect with a lot of people in our community that are doing great work. And it's just a really good time to come be a part of it. But right now, if you get your tickets at this moment, they are free, and that's pretty exciting. The other thing I wanted to point out is that something, Joe, and I think Ryan, you're probably also familiar with this, but every week there is a Cilium weekly meeting. You can actually see the meeting's Google Doc. There are meeting notes. And if you want to get involved or be a part of a release or talk about a feature or ask questions or pretty much anything to do with Cilium in that whole space, definitely come check out the weekly community meeting or come join us in Slack and ask your questions there in a more one-on-one fashion. I just wanted to share that with you before we get into the Cilium 1.15 release. So this is a preview of a blog post that's coming about it, but it's not out yet.
So I think, do you want to share that up on the screen, Duffie?
Oh no,
keen to check that out.
I've been talking this whole time. All right, let me do that. Yes, so here's the CNCF hosted events that I was actually showing you, but you couldn't see it because I forgot to actually share my screen. And here is the Cloud Native Rejects website, where your tickets are free at this point. So definitely go check it out. All of those will be linked in the notes for this week. Here is the Cilium 115 release blog. And it's funny, I was actually just chatting with Joe about this. The release blog, although it has some really great things in it, you know, like we've done, we've upgraded to Gateway API 1.0 support, which introduces a bunch of new capabilities from the Gateway API side of things. We've done a bunch of cluster mesh scale increase. We've got some security optimizations and a bunch of other stuff that's happening. It's not a really big feature release. We're not introducing like a big change like we did in 114 or in 113 or in 112 or like the last few. But I will say that it does feel to me like a big stabilization release. I'm curious to hear your thoughts on that, Joe.
Yeah, I mean, I think with like particularly 114, we had a bunch of quite sort of architecture changing or like significant big new features coming out.
Mm-hmm.
Choice education, of course, Gateway API, maybe 0.8 or something like that. And yeah, like so Gateway API, for instance, has gone 1.0 in the last few months. So this will be the first release that we support Gateway API 1.0. It comes with the gRPC routes support, stuff like that. But yeah, I think stabilizing what we've been kind of developing as like brand new stuff, I think that's the path to production for a lot of this stuff, and actually give people confidence to be able to deploy it and use it.
Yeah, tons of stuff going in there. Another thing that we're introducing or that has changed has been like the level of scale for things like cluster mesh. And so, Brian, I want to turn it over to you to kind of go over the work that you have done there. I'm going to pull my presentation and make yours available. There you go.
Sweet. Yeah, so this is just on the show notes. I added a bunch of notes in here that we can go through. So there were two main components in this release that we did to help boost cluster mesh scalability. One I'll talk about first here, which is KV store mesh. So we did some testing with cluster mesh and noticed a couple of issues. And as a result, kind of pivoted towards this new architecture for cluster mesh to help boost scale. And essentially the goal was to reduce resources consumption. So when we talk about cluster mesh, the default deployment method that we use is called the cluster mesh API server. And so essentially what happens is that in order for cluster mesh connectivity to be enabled, Cilium agents have to become aware of one another, especially across cluster. And so in order to sync this information, there needs to be a system in place. And the cluster mesh API server is that system. So the Cilium operator and the Cilium agent will do all their updating with Kubernetes API server. And then the cluster mesh API server watches for those changes for specific resources and then clones those resources into its own etcd deployment that kind of runs in the pod. And then what happens is that Cilium agents running in other clusters will watch the cluster mesh API server etcd for changes to those resources and kind of pull from there in order to do this information syncing. So every Cilium agent is watching every cluster's cluster mesh API server deployment for changes. And when you think about it, it's and like try to visualize it, there's a lot of different cross connections that are happening. Like when we tried to graph that architecture, there was a whole bunch of lines. It was very difficult to read. So we did some testing in it just to kind of understand the scale, and we can gather some data on it. And essentially, what we tried to do was we created an environment with 256 clusters all joined together, and then we tried to slowly increase the number of nodes in that environment to 50,000. And granted, when I say node, I'm talking about sort of a mocked node. Under this more information here, I gave a talk at CiliumCon in Chicago that kind of goes into more of what that looks like. But I can just refer to it as node for now. And so as we continue to scale this environment out, we saw that everything kind of stopped functioning at 45,000 nodes. And what was cool is that we were able to, with all the metrics that we gathered, we were able to pinpoint the cause. And essentially the etcd in the ClusterMesh API server was just unable to keep up with all the load. So at this point in time, etcd was consuming 50 cores, which is quite a bit. And additionally, it began dropping watches from Cilium agents. So at some point, we're hypothesizing that CPU usage just became too saturated. It couldn't keep up. Watches started dropping, and then eventually just kept trying to recover. But one interesting thing is that we also found an issue with etcd leases, and we actually published this upstream and was able to get a fix in. But essentially what we found was that the time of a put request to etcd when you're modifying the value for a key increases linearly based on the number of leases that are attached to that key. Or based on the number of keys that are attached to a lease, excuse me.
So keys attached to a lease, so we're talking like effectively the number of nodes in the cluster, or like how could you reason about that?
Yeah, so each resource that is in a ClusterMesh API server's etcd is attached to a single lease. Now, my familiarity with etcd leases, I need to do some more work to get up to speed on that. But we use that lease to sort of control garbage collection. And the problem was that because we were using a single lease, etcd was struggling with this bug, etcd was struggling on its own there to handle those put requests just because of some inefficiency. And so in the meantime, we had transferred to using more leases to handle that load. But I believe we were also able to get a fix in as well to help solve that. So that was just something cool. It always feels good to contribute upstream to other projects. So I wanted to point that out. Yeah, so we kind of see with like the architecture of the ClusterMesh API server having all these other Cilium agents trying to connect to it from across the entire mesh. Eventually, it's going to topple over just based on how that scales. So
yeah, I mean, like any given like program, like you're designing for a certain level of scale, and you understand like that's the goal of the project, right? That we want to reach that. And so when you start to push the limits, well, that's where it gets interesting, because like, okay, this is like it was designed for this. Now we're saying actually like there's people who want to use this at a bigger scale, and we say, okay, well, like what are the problems that we face at that level, and is there something new or cool that we can like develop to like make it scale even further? That's where the interesting problems are.
Yeah, for sure. Exactly. Yeah. I mean, because I think initially we just wanted to get something working, right? Something that we could just push out there and get some feedback on. But yeah, now we're at a point where we need to go further. And so that's where we kind of started working on KB store mesh. And so what we do here is we give more roles to the ClusterMesh API server. So we still have this functionality where the KB store mesh API server, in this case, is watching Kubernetes and replicating those target resources into its etcd. But rather than having all Cilium agents in a cluster reach out to every other KB store mesh API server, we have only the KB store mesh API servers communicate with each other. And then the Cilium agents inside a cluster talk to their in-cluster KB store mesh API server to pull these in, or to pull those changes in. And so immediately the number of clients that you get per etcd instance drops like by a factor, a scale. I don't know what the right term is, but
so like when you're talking about the testing and having like 50K nodes and like 250 clusters, or those sorts of numbers, are we talking about like 5K nodes per cluster, and then now you're saying there's only going to be 5K watchers on like one of these KB store mesh instances, instead of having like 50K nodes all hammering each of those instances in the other cluster?
Exactly. Yeah, that's exactly right. Because the number of watches on the ClusterMesh API server scales by the number of clusters multiplied by the number of clusters in each node. But now, as you're saying, it's just the number of nodes in a cluster. plus however many clusters there are.
It's just like some flat number, like sub 1,000, I guess.
Yeah. Exactly. Yeah. Which just kind of brings us back to the other change that we made, which we can talk about in a bit, about increasing the maximum limit of the number of clusters in a mesh, which is also in here in this release. But yeah, so when we started doing more testing with KV Store Mesh, it was able to complete the benchmark that we tried to do with the Cluster Mesh API server, with ease. It used less than a core, less than a gig of memory, and was able to just complete the whole test, which was something we weren't able to do before, which is pretty nice. And so I think another thing to point out here too is that not only do you get to be able to increase the total number of nodes in your mesh, but you kind of get to more evenly spread the load that it takes to run your mesh, as well as kind of have some isolated failure domains. Because what happens is, let's say that there is a cluster in a Cluster Mesh API server case, right? A cluster that the connection between that cluster and a Cluster Mesh API server instance just fails for whatever reason. When those sorry?
I said, oh, wow.
Yeah, I mean it could happen, right? When those nodes in that cluster try to rejoin and rewatch on that Cluster Mesh API server instance, each of those nodes is going to try to grab all the information in etcd at a time, and that can be overwhelming for
so you got kind of thundering herd sort of situation almost.
Yeah. Exactly. Yeah. But with KV Store Mesh, you just have one instance trying to redo that watch, and then the KV Store Mesh instance inside the cluster is the thing that could get hammered instead. But it'd be better to have a single cluster affected rather than the entire mesh, because as that one Cluster Mesh API server instance is hit with a thundering herd, it could impact other members in a different cluster, for instance. And so that's kind of also one of the main advantages that KV Store Mesh brings, is having that sort of isolation there, and kind of spreading the load more evenly, which is kind of nice.
Very cool.
Yeah.
That is neat. Yeah.
I
was actually just looking at this paper this blog post by Lindsay Cooper, who was talking about, who is a distributed systems expert, and was doing some research into the CAP theorem and trade-offs. And this one in particular is super interesting to me and kind of related, because she in this blog, she's actually describing a trade-off that Kubernetes itself has. It's a bug that was filed in 2018 that came upon a discussion that talks about a CAP trade-off in the wild, in which effectively, because Kubernetes in a highly available scenario, it has like a 3 etcd nodes in a cluster, but then it also has generally 3 or 2 API servers in front of those etcd servers. And each of the API servers has a cache, and caching is replication, which means that you have made the trade-off to support the cache over the replication of what's happening back in the etcd side of things. So this leads to a behavior which is identified by the bug report, wherein, like in a highly available Kubernetes environment, if there were a network partition, you could effectively deploy the very same pod with the very same configuration on 2 different nodes, because you're both getting it from the cache. Right? So there's no actual guarantee of consistency when in this scenario, because you now have the 2 API servers and their caching mechanism in front of the thing that would guarantee that uniqueness.
Which so is there's no sort of like architectural delegation to certain caches, just
right?
You're responsible for this.
Be.
It's like,
yeah,
so there's no consistent, well, not consistency at that level.
Yeah, and it's interesting. Like, I mean, I actually don't know that they've solved it. I think the bug is still open, and I don't know. I know that in the wild it doesn't happen very often, but it is a fascinating problem because it does talk about the fact that once you start introducing caches, you also introduce a behavioral change that might change the assumptions that you had before those caches existed, which is the super fascinating part to me anyway. Well, thank you,
Yeah,
Ryan,
that's
for
interesting. Oh, sure. Yeah, no problem.
we do actually have somebody, OMG, posted, when is 115 available? And actually, the RCs are actually out right now. So if you want to try them out, they're available even as we speak. But I think the actual release is scheduled for next week. Or
Yeah, we'll put out like a couple of release candidates. We've had a lot of good feedback from the community. Bug fixes, we're fixing things up. I think we've got like 1 or 2 blockers left. So we're hoping to finally publish next week.
Yeah. Excellent. Yeah, I know there's been a lot of work to try and get that out. In fact, I think we should probably I will show you how we could try this out. So while we're still here and we have a little bit of time left, what time is it? We're doing good. It's 11:26. So while we're still here and we have a little time left, I'm going to go ahead and show you how you can leverage the Cilium CLI and the kind application to bring up a cluster and try out a pre-release of Cilium. So let's go ahead and get this started. So what I'm going to do is I'm going to bring up a kind cluster with the following config. This is the configuration of the kind cluster that I'm going to pass. I'm going to create 1 control plane worker and three worker nodes. And then the kind configuration in here, it provides you a lot of options, and you could read a lot more about them if you go to kind.sigs.k8s.io. That's where the kind project is documented, and you can find a lot more information in configuration and a bunch of other good stuff in there. But in our case, we're going to disable the default CNI because we're going to install our own. So let's go ahead and do that. Kind create cluster config. And we'll wait for this to come up, which happens pretty quick. For those of you unfamiliar with the Kind project, Kind is basically a way to bring up nodes that are governed by systemd inside of Docker. So each of the nodes in my cluster is a Docker container running systemd, where it can run the kubelet application, it can run the API server, it can do all of these things. It in itself can actually run its own container systems. So like all of the file systems that those containers actually see are available only on the Docker container where that particular node is running. So it's a weird inception kind of moment. Another interesting thing about kind clusters is that because they're all Docker containers, all of the nodes are Docker containers, they all share the same kernel, right? They all have the exact same kernel at the top. We do a kubectl get nodes, we can see they're all in a not ready state, and that's because we don't have a CNI installed. If we do a get pods-aw, you can see I have a kube proxy installed and running. We can see that core DNS is still pending because, again, we don't have Cilium installed. Cilium, in the past, I've shown that Cilium actually has an auto-discovery mechanism where it can discover the configuration of the cluster to some degree and provide you some tips on how to configure Cilium for those particular environments. And it can do this automatically. If you do Cilium install, if I were just to do Cilium install, we would see some commands about what's actually happening there. And I'm going to do that, but before I do that, I'm going to also do install list versions. So this command here, Cilium install list versions. And you can see all the versions that are known about today, right? So as it stands right now, we know about RC0, we know about pre3, pre2, pre1, and pre0. So let's go ahead and try to install V115 RC0 in our cluster here. So Cilium install version 1. V115-RC0. Now, it auto-detected that the Kubernetes environment that I was deploying was kind, and it's running the kind validation checks. and it detects that the version of kind that I'm running is version 0.20.0. It detected that kubeproxy has been installed. You can actually also see for your own, if you're curious about this, you can do Cilium install just like I did with this command, but you can also add this other flag to it, which is pretty useful. I run Helm values. This won't do an install because what this is going to do is basically do a dry run, but it will take everything it learned about the cluster and then share with you how it's going to go about configuring it. So in our case, it's going to set it in tunnel mode. It's going to use the IPAM mode Kubernetes because we're using a kind cluster, and that will work there. The tunnel protocol will be VXLAN, and here are basically and it's only going to set one replica for the operator. So the other replica, usually it's a deployment of 2 replicas, but it gets it down to 1 because it's only a kind cluster here. So that's what we can learn from that. If we do kubectl get pods-aw again, we can see Cilium is up and running on all nodes. So this is a way of installing and seeing and playing with the Cilium configurations that you want to explore in pre-releases. So in my case, if I wanted to actually explore, like, I don't know, the new BGP community stuff or some of the new gateway API stuff with gRPC routes, this is a way of installing a pre-release of Cilium that you could configure to explore those things, which is pretty neat stuff. So very, very accessible, very easy, very, very cool to see this stuff. There's lots of really great stuff happening in that space. And the last thing, I wanted to go back to the blog post and make sure we had a good amount of coverage here. So we have talked about introducing Gateway API 1.0, which is the next generation of it. And that's built directly into Cilium, which is very exciting. So you don't have to have extra tools. You just turn that feature on in the Helm chart, and away it goes. The Cilium Gateway API now supports gRPC route, as Joe had mentioned, alongside additional features like the ability to redirect, rewrite, and mirror HTTP traffic. And that's pretty exciting. And Jay also agrees. That's pretty awesome. Cilium 115 also has a ton of improvements into BGP. So BGP sessions now support MD5-based authentication. The Envoy that we use for layer 7 processing and observability within by Cilium, anywhere we can't do it with eBPF, we do it with Envoy, has actually just seen some changes to its security posture. The cluster mesh operators will see some major improvements. You can now double the number of mesh clusters. We just discussed why that is and how that will work. That's pretty exciting. Operators of managed Kubernetes environments like EKS and AKS have also been given lots of improvements in the last few months. Lots and lots of changes. I mean, this really kind of aligns with what we were describing so far, which is that there's tons and tons of stability work going into the release this time. A new change in the Hubble flow in Hubble flows allows you to correlate traffic to a network policy. Pretty exciting, which means that you can actually see in the event, you can actually see which network policy allowed or denied a particular amount of a particular flow of traffic, if there is one. You'll be able to see that now. And then there's also an expansion in Hubble that allows you to see more information or to do more filtering. So before you could kind of filter, you could say, 2 FQDN, and you could use 2 FQDN to filter on particular websites that were being accessed by workloads within your cluster. And now you can actually even search into the headers and stuff like that, which is pretty cool. So if you're looking for a particular key value in an HTTP header and you have HTTP visibility turned on, you'll be able to actually parse the Cilium event data and see and filter on just those things, which are pretty exciting. Yeah. All right. And we've added, of course, the 128, 129 support, which is just means basically more testing targets and those sorts of things. There is a new Cilium provider, which is pretty neat. And there's now a redact, so you can remove sensitive information from Hubble output. Lots of great stuff. Yeah. All right. And we are also updating a bunch of here's an example of the gRPC route for the Gateway API mechanism. But we're also updating a bunch of the labs. And I do want to show you once again where those labs are. If you go to isovalent.com/labs, these labs will be updated. We're going to be releasing these again next week. And a bunch of these labs will be updated to the 1.15 series. So you'll be able to do things like try out BGP with MD5 authentication. You'll be able to do a lot of that stuff. And those use cases will be things that you can explore without having to deploy all this stuff in your own infrastructure. You can just try them out, see how they work, make sure they work the way that you expect. And then when you're ready, you can actually move those things into your own infrastructure. So this is the first of 2 episodes, as I mentioned, next Friday, much earlier Pacific time. I think it's like 6 a.m. Pacific time. But it's the European time zone one. We have Nico hosting an incredible list of guests coming up in next week. We're going to have a lot of our external contributors coming on to the eCHO office hours and talking about their experience contributing to Kubernetes or contributing to Cilium, and that'll be a really fun show. I'm really looking forward to that one. The awesome thing about that one is, like, it's funny. I've done this episode before as well, but it seems like this time we had more external contributors from Europe. So like a lot of the folks that are contributing externally are actually in the European time zone. So they're going to be hosting that in the European one coming up next Friday. And I hope that you will be there and go and check it out. Gentlemen, I want to thank you both for joining me. I hope that you had fun. I know I had a great time.
Yeah, thanks for having us.
Sure. Yeah, thank you.
Awesome. We'll see you all next. I hope you all have a wonderful weekend, and I look forward to seeing as many of you as possible in Paris and also at Rejects. Remember that if you haven't already booked your flight and you're planning on going to Paris for KubeCon, definitely check out Rejects. Even if it's just the day before, there's lots of really great talks. It's a really great opportunity to connect with the community before you get completely run over by what's happening at the event, because there's so much happening at the event that you have no time to really spend with people. But I feel like Rejects really gives you that opportunity to connect, which is awesome. All right. Thank you all.
All right, thank you.
Hey,
Let me go down to Brand. Bye.